Transformers. Cool. Let's see. Something with the cat is still for the Transformers, but this is going to start from scratch because I know this is like the fun part, I think, of the game where like I've already been hanging out over here in like the XP curve, and like I've been doing a lot of machine learning stuff, but I never actually learned this stuff. So now I get to back into it, which is way more fun than like spending a bunch of time with a bunch of boring shit that you don't know what it's for, and then eventually on the promise, maybe someday you'll get to do the fun stuff. So XP level fun. I don't know. I don't know how to do this. How do I do that? It's like this? No. No? Wait. I have a tablet, you see. And now all of you fuckers are doomed. Alright, what this shit is a transformer. It's a thing. It does a stuff. Nope. It's like, I've never felt more professorial than when I'm just like writing and talking at the same time. Oh yeah, of course. It's like a guy. And he goes to the dog. Look out. He's got... What's wrong with your dog? I should be doing this in Blender. That'd be cooler. Later. This is Krita. It's also Foss. Focus. Someone run tutorials for your class. Interesting. One of the rules of Free MoCap Foundation is educational material is free, always, but labor is very expensive. So, like, hey, here's our tutorials. Would you like a person to come help you run them? I like that. That's great. We do like Hugging Face. It's a very trustworthy emoji. And if you don't know, okay. Blah, blah, blah. And I do this. Just give me to the part where you can track my cat. Okay? Because DLC actually could handle it, but I want to give it a help. And transformer Python Hugging Face. No, yeah, this guy. I honestly probably should just be starting here, but I want to go through the tutorial. But it's this one you see. This is the one. This is the one that we want. See how this says cat? It's like, boom, you fucking nailed that. 2 cats and 2 remotes? Why would you ever need 2 remotes? Those look like the same TV. No, they're not. They're totally different. Yeah. So pre-crop it. I just want to crop the cat out with the Transformers because Deep Lab Cut, I don't trust your shit. Sorry. I don't trust, like, you have it in there, but it's like, I don't trust it and I don't know how to get into it. Whereas this thing is currently in the process of unmaking the world. So it's got a few more eyes on it, you know. Fork everything. It's like, if I can fork it, I do. It's like, oh, that's interesting code. It's mine now. I should set up a cron job to pull locals. Anyway, okay. Yeah, so they're going to start with NLP. Mostly because it's nice because it's one-dimensional, because it's just like a sentence. But then the computer vision is just like, oh, and then also you can do it in 2D and it's fine. It's like, cool. What about 3? It's like, probably. I think that's nerfs. I think nerfs are when they push it to 3D. Okay. Blah, blah, blah. It's super cool. Blah, blah, blah. What is transfer learning? I was. Okay. You get this from my desktop? Mm-hmm. Mm-hmm. Yep. Okay. I don't know if you want me. I don't know how this audio is going to sound, but I'm just going to turn the desktop pretty low. It might be coming into the mic. I don't know. Who cares? When training from scratch, all of those ways are initialized randomly. In this example, if we're training the platform, and the recognizing two differences are similar on it. So epoch is like the training, like the training run, I guess, and then validation loss is validation loss. So it's like validating. It's like the network's guess against the provided data. So we know that this is the right answer. We assume it's the right answer because the human said it was the right answer. And so now here we are, a machine, and we validate, and it's like high numbers are bad because it's loss. Loss is bad. So something accuracy should go up, loss should go down. This is kind of middling. Validation is okay. Training from scratch, so it's hanging out. Actually, fine tuning a pre-trained model. Okay, yeah, accuracy is higher. Training from scratch requires more data and more compute to achieve comparable results. Yeah, cool. On the left, it's training from scratch, and on the right, it's fine tuning the trained model. As you can see, using transfer learning to train model. Oh. As we can see, didn't you see that? Do you see that? Obviously, machine learning people, they love their fucking tables of like, oh, check out this fucking table of floats. Get it? Wonderful. So glad we could be on the same page here. Bless your heart, my dude. Bless your fucking heart. It's weird being older. Just weird getting older. That's all I gotta say. Cause it's like I get stuck between the space of like, good job, my dude, you're killing it. Like that's amazing. Like you're like the professor thing, and also the space of like, this could be better. Cause like there's a point of complexity that's being missed here, and I don't know if he gets it or if it's just kind of he does get it, but it's like he was like a presentation thing. It's like, oh, it maxes out at 70%, but this one gets much better. And it's like, well, this one used to be that one, right? You can start from scratch, like the route goes like this, like. This is because trained models are usually trained on large amounts of data, but providing with statistical understanding was enough we choose to train. In computer vision, transfer learning has been applied successfully for almost 10 years. Yeah, so ImageNet ImageNet is crazy. ImageNet is like the first time, arguably ImageNet is like, I think ImageNet is the first example that I know of off the top of my head. No, that's not true. I was gonna say it's the one where like it started to achieve human level performance in classifying images. But I think like the older one would have been like the Rummel-Hart and whoever the fuck in 86, where they introduced backpropagation, I believe doing optical character recognition, like categorizing, like I think it was 1, 2, 3, like 1 through 9, and the computer had to identify which one was which. And I think that one probably did achieve human level performance because it was such a constrained task. But still pretty fucking wild. Anyways, what are you doing? Each image is satisfied by one of 1,000 levels. Training of this on latest data is called supervised learning. In natural language processing, supervised learning, meaning I tell you what the right answer is. Did you get the right answer? I am human. I am God. I know everything. Everything I say is true, is what the computer believes. So I know the right answer. So I'm going to see if you know the right answer, which is as opposed to unsupervised learning, which is I push you out into the forest and I say, go find a flower. And it's like, I don't know what a flower is. It's like a much harder task. Transfer learning is a bit more recent. The key difference with ImageNet is that the training is usually self-supervised. Okay. It's possible that there's just terms being used differently because this is a different space. Like I don't know. Like also the machine learning community not careful with their language. They all because developers always invent everything from scratch because they don't know that you're not supposed to do that. So people regularly just like reuse names and stuff like that. Like pose is often referred to like this is why like in FreeMocap like I don't call the base body data pose data because that word is also used in a very nearby field called computer vision to reference like the position of the camera relative to some calibration object. And it's like, yes, I know that technically both things involve like the position of a 3D thing in space, but like don't call the if it don't give me a data set that is pose, hands, and face. Just can we please can we please
Which means it doesn't require documentation for data. The original training objective is to guess the next word in a sentence.
uh-huh.
It requires lots of text. GPT-2, for instance, was retrained this way using the content of 45 million links posted by users on Reddit. Another example of self-supervised training objective is to predict the value of randomly matched words, which is similar to filling reference tests in relevant. But was retrained this way using the English Wikipedia and 500,000 links.
Uh-huh. Yeah.
Also running the file even more by training.
So okay. Yeah. So the thing that he didn't the thing of transfer learning is a bit more recent is the part where I'm really trying to figure out if he's gonna because it's like so transfer learning as I understand it is you start with a model over here and I think you duplicate it and then you start thinking of this one as being trained for a different task. I did this, right? So we do this. So I start with this model. It's named A. And it does a certain thing, and it's got a bunch of data that trains it, and it can do a certain thing. And I can keep training it to do this like A task, but I also want this other task over here called B. I'm kind of checking my knowledge here. I might be wrong about this stuff. And naively, you might think that what we can do is just throw a bunch of, let's see, oh, Jesus, fuck. What just happened? Oh, I clicked the thing. Ah. Oh, no. Oh, no. Okay, we're good. That was close. Ah. Let me full screen this shit? Hey. Detached canvas. Ooh. Sure. Why not? Now I gotta figure out how to make the back part of this be an eraser. Oh shoot, but I lost the thing. No, I got this thing. Wahahahahahaha. What's up, Pooh? Thank you, kitty. Ooh, white colors. Right, wait, no, this color. Yeah, so we got a bunch of A data that goes into an A model that can do the A task. Great. And we also have a bunch of like B data. Let's say A data is like recognizing dogs. And so you give it a bunch of dog pictures and it becomes quite good at you give it a new picture, say, is this a dog? And it's like, yeah. But you also got a bunch of cats. And cats are kind of like dogs. And so you might think that you can sort of take your dog detector. A dog. B cat. You can take your dog detector and start feeding it a bunch of cat pictures and say, oh yeah, no, this is a dog or a cat. But like these things are bad at doing that. Like neural networks, like transformers maybe like I'm thinking about like older school neural networks. Transformers are a little bit of a different thing, but like not that different. It's still a bunch of connected nodes and statistics. But yeah, they don't like to do two things. Specialization is easier than generalization. So you might think that you can just start, like, you feed your dog pictures into your cat pictures into your dog detector, and then all of a sudden you got a thing that can do two things, but they tend to fail. You get what's called like catastrophic forgetting, and they just like, it just stops being able to do anything. It starts calling everything a donkey. So what you could do is start training up your cat detector, and then all of a sudden you get a good cat detector, and you could do that, and that absolutely works. But what he's saying here in this slide actually is like, this is expensive and it takes a long time. So what would be nicer is if you could just, I don't know what we're gonna do. What's between? Sure. Is if you could just kind of like take a copy of this A dog detector, start feeding it in all your cat data, and then it becomes a new model that is your cat detector, and then it can start detecting cats. And and what this is saying is that this thing it's way faster to do that, because you've already done the job of training a dog detector, and it's already pretty good at detecting like mammals and furry things and quadrupeds, and like you've already done a lot. Like, it can tell, like, you don't have to tell it that like this is not a cat or a dog. Like, it's like that's something that it's already got that. So you get to take advantage of that training and sort of then just like shift to specialization. So anyways.
The training construction is kept around 70% accuracy, but the train model is 86% easy. This is because the train models are usually trained on large amounts of data that provides the model with statistical understanding of the number it used during training. In computer vision, transfer learning has been applied successfully for almost 10 years. Models are frequently trained.
Almost 10 years, huh? That's how long we've been working on that? Wow. Shit, we've really been cranking, huh? These past 10 years. God, man. I wonder which white German guy is the one who invented it. Who started it in, what is this, 2022? So which tell me, in 2012, who did it first? Jesus fucking Christ. It's one long conversation, y'all. Nothing has ever started. It's just a continuous fucking river into the sea of whatever this shit. Almost 10 years. Almost 10 full years? That's the one. No, we're good. We're good. I love you. My dude, you're spectacular. You're doing such a great job. For real. Like, legitimately. I have in my heart, you see, in my heart, I have this. We don't get this. The concept of teaching, where I'm up here and here's all the students, and this is my classroom, and the purpose of the teaching is to make them compete with each other and evaluate them relative to their peers in order to figure out which one of them should be able to make it through the gate. I'm going to use this most aggressive color I can. Fuck that shit. So, and unfortunately, like, so part of that is like this confusion that I currently have of like, how do I evaluate the work of younger people? Because if I'm looking at them, see, that's too aggressive now. There we go, chill. Like, I'm like, oh yeah, like that. Look at this one. You're doing great, actually. Like, relative to like your context, you're doing spectacular. But also, like, it's fucking not even close to what it should be. Like, it's not like where it needs to be for us to be able to like the problems of the world. It's not even close. So I don't know what to do. And like, and believe me, if I was pointing that at myself, I'm not fucking better. So am I going to evaluate you relative to your peers, or am I going to evaluate you relative to myself? Because I gotta be honest, I don't think you're ready for this fucking heat. Like, but ultimately, like, we are up against a very big fish, and he's a very mean fish. And I need all hands on deck. And I need you to be as good as you can possibly be. And I need you to be on a trajectory to get way the fuck better at this than I am very quickly because I'm so tired. Oh, dearie me. But you're doing great. You're doing really good. And I want you to keep it up because whoever you are, your trajectory is unbelievable. But I don't want you to lose track of of you see the situation because the scary fish is coming and we're not ready for it. See, it's a fish. Okay.
That the training is usually self-supervised, which means it doesn't require documentation for the labels. The very common training objective is to guess the next word in a sentence, which only requires certain text. GPT-2, for instance, was retrained this way using the content of 45 million links posted by users and read.
It's like,
Another example of self-supervised training objective is to predict the value of randomly matched words, which is similar to the different text you may have done.
and so like, so he's kind of got the vibe of like, it's so hard to tell with Germans or those Central European folks because, like me, they avoid the deadly lasers of Mr. Sun, and so it's really hard to tell how old they are. He gives me the vibe of like a late-term grad student who kind of has a familiarity and understanding of the core concepts, but lacks some of the broader context, like the historical context, for example. And then it's hard to know. Well, he probably was never taught because it was never emphasized because it tends not to be emphasized. And so that's why it's like studenty talk of like, oh yeah, we started this 10 years ago. It's like, I understand that that's the oldest paper I've made you read about this, but this stretches back to the fucking Babylonians. This stretches, I don't know, the fucking Flint Nappers in Olduvai Gorge, man. Like, I don't know, like, I mean, anyway.
In practice, once you're learning the time, you can more. Throwing away its head. That is, yeah.
And so basically, so what this is saying, GPT-2 is trained. It's like this is like a thing because also this is like Claude Shannon shit, man. Like at least. So it's like if I give you the word my and you had to, if I don't give you anything and I say what am I going to say next, you're like how the fuck should I know? Best you can do is to go with context. What do you know about me? Where are we having the conversation? Whatever. But if I say the word my and I say what's the next word I'm going to say, all of a sudden the possibility spaces can constrained a lot, like from, infinite numbers of possible things I could say. So now it's like, well, I mean, my is like a possessive, so it's going to be a thing you possess, and so like it's going to be a noun, and so you can predict things like name. And then if I say my name, it's very likely that I'm going to say is next. I could say my name has, my name will, my name will live forever, stuff like that. But it's much more likely that those are all weird things to say, whereas my name is much more common. So at this point, you're getting pretty confident that you can say is. Now, if it's me, my name is John. If I say my name is, it's actually pretty unlikely that I'm going to say Sylvain. Are you Sylvain? And then I guess if you can hear my punctuation, then you can guess the punctuation. But this is the one-dimensional thing. And what I'm describing of like the predictive aspect, that's just like a forward model, like you're always predicting the next one. And then transformers, which is going to get to it presumably at some point, their main shtick is that they know it's a technique to keep in mind the local context of like, oh, my name is Sylvain. I'm going to give Sylvain. Like keeping that statistics in mind while also keeping in broader statistics. So it's like, oh, wait, like we are in a we're in a house, I'm talking to a guy, like this is broader context than just a sentence. And transformers have a fancy mechanism for allowing like the local context and the global context to both inform the next output, otherwise known as like how how you should do it.
Was retrained this way using the content of 45 million links posted by users and read. Another example of self-supervised training objective is to predict the value of random math scores, which is similar to field deployment tests.
Same thing, just
Was retrained this way using English Wikipedia and 11,000
same thing, easier. Because you know the front end, you know on by the other side. In practice, transfer learning is applied on a given model by throwing away its head. Oh, great, thank you. We throw away its head. Nice. Glad we do that. That's definitely the easiest and most direct way to explain this to people that don't know what's going on here. You just head and body. It's like, have we talked about that yet? I don't know.
That is, let's say your focus on the training objective, and replace it with a new, randomly initialized head suitable for the data set.
See, I don't even know what the head is. Like, I kind of do. The head, I'm guessing, I don't know what the fucking head is. But yeah, here's the same transfer learning task thing. See? Doink, doink. And then what's the head? I guess the head is the output? What the fuck is the head? I don't want to ask.
When we fine-tune the model earlier, we remove the head that specified math scores and replace it with classifier with two outputs, since our task had three rows. To be as efficient as possible, the retrained model use should be as similar as possible to the task fine-tuned now. For instance, if the problem is to classify German sentences, it's best to use the German retrained model. But with the good comes the bad. The retrained model does not only transfer its knowledge.
I love that. With the good comes the bad. With the good comes the bad. Let's say it again.
German sentences, it's best to use the German retrained model. But with the good comes the bad.
The good comes the bad.
If the problem is to classify German sentences, it's best to use.
You can't hear that. Oh, I'm sorry. Here you go.
German retrained model. But with the good comes the bad.
Okay, we're back.
The retrained model does not only transfer its knowledge, but also any bias it may contain. ImageNet mostly contains images coming from the United States and Western Europe. Models fine-tuned with it usually will perform better on images from these countries. OpenAI also studies the bias in the prediction with its GPT-3 model. For objectives, to almost any physical bias.
Yeah, no shit. They're trained by they got bias. Blah blah blah.
And this wedges its use in systems that interact with humans.
OpenAI studied the bias predictions. Yeah. Sure they have. Okay. Great. Thank you. Great job. A+. Fuck reading. Okay. This is kind of wild that you can do a YouTube video in there. What is capture? Yeah. Wait, are we here? Are you running? Capture. Run the cell, capturing standout in IPython's rich display calls. What's the difference, though? Oh, I think it's don't gunk it. It's the opposite of what I thought. It's capturing it being like don't display it, right? Oh, if unspecified captured output is discarded. Gotcha. So it's like a redirect, but if you don't redirect it, it just goes away. Cool. Now we saw the libraries, looking at applications, we got the sentences. Fastest lane learners do what we call the pipeline function. Okay, I like that. Can we put it back? Huh. Yeah, but go back into your house. Aha. Okay. So yeah, pre-processing. I will watch you again, but I will try not to be so slow about it.
Look at what actually happens when we use the pipeline function on the transformer level.
Okay, sentiment analysis, classifier. I hate this so much. Okay. Label is positive, score is that. So it comes out with little blurbs. Yeah, okay.
Well, look at the sentiment analysis pipeline. And then we went from the two following sentences. We convert the word text to numbers. So the organic sense of the tokenizer.
Alright, I gotta listen.
There are three stages in the two following sentences when we use the pipeline function on the transformer level. Or specifically, well, look at the sentiment analysis pipeline. And then we went from the two following sentences to positive and negative labels with respective source. As we've seen in the pipeline presentation, there are three stages in the pipeline. First, we convert the word text to numbers from the organic sense of.
Yeah, tokenizing. Tokenize it. It's like you chop up the sentence. You don't just give it like every single character. You have like you tokenize it because it's like the letters THE. You know, they don't always like. It's like it makes sense to keep those together. That's actually some Claude Shannon shit. Like that sort of the idea that when you're like condensing English text into tokens is that's old shit. Old like to the 50s, but like you know, that was arguably the start of like modern like he's credited as inventing like information theory, which this is all directly out of. If you would like to know more, the information gleek. This. If you would like to know more. Oop. Okay, so raw. Okay, it's using a tokenizer. Those numbers go through the model, which outputs logits. Which outputs logits. Okay, so let's assume that that this is corresponding. So okay, so this is staggered on purpose. So the raw text goes into the tokenizer, which produces tokens, which goes into the model, which produces logits, and then there goes into post-processing, which produces some kind of human-readable thing like the scores and stuff. Yeah. Nice. I think from a presentation perspective, I think you had plenty of room on this slide to like. I want to be able to draw on this screen. I really want to be able to do that. I'll figure that out eventually. It's just there's something not quite working with it. But you could have moved these up here and just have it be one flow. Because right now, like I had to in my head. You saw me do it. I had to make the connection here, and I thought it was like offset, and I was like, oh, it goes like this. but it doesn't. You could just move them up here. You've plenty of room, and take up more room in the space. And I don't know. It's just I think there's a way to condense this. I think that would have been nicer. I got distracted thinking about how weird it is to be that, like, I'm critiquing someone. This is just professor mode, man. Like, I just can't not do this. I look at each of these steps in detail and how to replicate them using the Transformers library. Sure, weird way to say that, but sure, why not? Yeah, but like the tokens are smaller than this. The tokens are not words. They're smaller than words. So like amazing would probably be cut into two. Like this is probably a token. Is definitely a token. But if is a token, would this might be THI, like I can't remember how this works exactly. This is beyond my depth. But I do know that like this is like there's not a token for amazing, at least not in the OpenAI, like the GPT-4 stuff. But you have different tokenization schema, so you could just as easily just make one. I think you can just make one that does just say split it by the white space and call it good. Oh, he says that. Yeah, he says that. Oh, interesting. So these are like the start and stop tokens. But these are binding? Okay. Because I keep seeing references in a lot of the like the GPT-4 code, like on like LangChain and stuff like that, about like binding stop tokens and stuff like that. It was one of those weird moments. Like I see it in places. I'm like, I don't really know what that means. So in this context, it looks like you got CLS, which whatever that stands for, and is like some start, and then SEP would be like end or stop. I don't know. Like there's some ordinality to it. Say presumably. Yeah. Sure, but what are those? Why? Well, so this is one of the things. Like, why did you say CLS and SEP? And not start and stop, like, so it's in, because like I do a lot of like complaining about like, oh, you should have done this, it's clear. This is one of those things where it's like you're referencing something. This is something else. You're talking like that's not random. You're referencing a thing that I've never seen or heard of. That's a shibboleth that I'm failing. And if I were to dig into that, I would learn some little piece of depth that like he didn't even think to say, but he referenced it with like, he's like, oh yeah, of course I'd put CLS and SEP here, of course, yeah, culture, I'm part of in this culture, that's what we do. And it's just like, why? It's like, oh, because it's a reference to some other thing. It's like I would never say that in an intro course because it's too deep and it's too specific. And it's like, yeah, okay, all right, this is the opportunity to dive deeper, which I am not going to take. Yeah, so you have like a dictionary, and it's like it gives you like the ID is an integer. Just like this is it. I have 3,000 total tokens, and you've used these ones, and here they are. And it's like this is also seems like too specific to be made up. Like CLS as 101, and so the start one as 101 and the end one as 102. It's like oh, you might be actually. This might be like you're referencing something. Like there's something else going on here. Let's see here. From pre-trained checkpoint. Distill BERT. I've seen a lot of BERT. I don't really know what BERT is, but I think BERT's some like progenitor language model. Get me to the kitties. Okay. And a tensor is just a matrix. A tensor is, this is another one that I was like like furious about for a long time. A tensor is a matrix, and a matrix is just like a square or a cube or a hypercube or whatever of numbers. And when I said hypercube and you freaked out, like just know that when I said line, square, cube, hypercube, same fucking thing. It's like a line is one line, a square is two lines that are right angles to each other, and it makes a square. Could be a rectangle, but there's right angles in there. A cube is a third line where all of these things are now. Oh, that's a nice way to draw a cube. Right angles to each other. And now there's also there's another one, and this goes into some dimension that we can't draw or think about very well, but it doesn't matter. It's just 4 numbers instead of 3. And so so this is a number. That's great. This is 2 numbers. We call that a vector, and you can multiply this by 3 and it becomes 6. You can multiply this by 3 and it becomes 4, 9, or whatever. But you can treat this number basically like this is one of the main tricks of linear algebra is like you can treat this square of numbers in very similar ways that you treat like one number. Like there's a couple different rules, but not that many. And if this was like a cube of numbers or like a hypercube of numbers, you can treat it like a regular number. The numbers just get bigger and there's more of them, but don't worry about it. And so a tensor is just one of these big honking square numbers, cube numbers, whatever. In MATLAB land, we call these matrices. In linear algebra, I think we also call them matrices. In machine learning, for some reason, they decided to call it tensors, which is, I think, tensors, the term tensor comes from like some fucking physics or something. I don't know. Like the hot one, what's the hot one? Heat one? Thermodynamics, I think. Or they don't. It's one of these things. Like people from different communities named the same thing in different words. It happened with information theory too. This book talks about that. Talks about that for entropy, where the thermodynamics physics people and the information theory computer science people both sort of like ran into and named entropy and from like different directions, which is why the term is used in such confusing ways of like, wait, entropy increases when randomness increases, but information is a crystal high entropy or low entropy? I can't remember because it has low information, but it has highly ordered, but has not information because there's no surprise when you see the next one. But if you get it, so it's like one of these things, like different cultures of learning often will you just name the same thing different names, and it's just confusing. So tensor is one of those where like if you see the word tensor and you're like but then I say the word matrix, you're like, oh yeah, it's the same thing. See, just a square of numbers.
Ja, checkpoint used by default to some of the devices by type is this is based on JScript here, this is to English, which is a little more good. When some shit is recognized associated with a checkpoint, then it needs to do sentences. Since the 2 sentences are the same size, we need to find the shortest one, the old minimum. Oh yeah, so you zero pad it because it has to be a rectangle. It can't be one long string. Like you can't stand it. Get out of here, you. Yeah, like if you have one of these and one of these, you can't have it. Like it has to be this shape. That has to be the shape. So either you can shape it like this and just cut all this off, or you can just do this and just like make fake zeros and then be able to fit everything in there. He's using zeros. Oftentimes you'll see that people use things called nans. Nan stands for not a number. And it's nicer than 0 because 0 is a number. So if I say, hey, what's 5 times, if you give me if I ask you for a number and you don't have a number to give me, like if I ask you for if this is 10, if I ask you for the 12th
thing in this first sentence. It's like, oh, there is no 12th thing in that first sentence. So let me give you this placeholder instead, because we had to put a placeholder in there so that we could put it into a rectangle and not lose any of the data. So if you give me a 0 and I multiply it by 5, I get 0. But if you give me a nan and I multiply it by 5, I get not a number. This is fake. This isn't real. And so depending on what your application is, sometimes like you want it to fail. Like you want it to be like, oh, I don't have data, so I'm not going to do anything. But then you have to have a system that can handle nans, which are not numbers. So if you're living in a world where you say, oh, these tensors and these matrices are just big square numbers, then you can't have some nan bullshit in there, because that's not a number explicitly. So you make these choices, and sometimes they are made mindfully, and sometimes they are not, because it's way easier to just stuff zeros. But sometimes that's not the right move. And I don't know if this is one of them. I would assume at this point that these guys are good at this. So, and this is how they do it. They give it an attention mask. So they're going to multiply each of these values by this number in order to tell the attention mechanism, which is a big part of the transformer later, how much it should pay attention to this part. And so the parts that are 0 are going to be multiplied by 0, so they're going to be given 0 weight. So they're basically backing their way into the not a number thing by having a two-step process of saying, like, these are empty, ignore them. Which, to be fair, like, that's under the hood, a nan is going to have to do something like that anyway. Okay, so we're living in PyTorch land, not TensorFlow land, I guess. It's fine. Squares and numbers. I've never done any of this shit before, by the way, just to be clear. I've encountered a lot of it. I've seen it done, but I've never really I've never trained a machine to learn, you see. I've just watched it done. Oh, it's in the token. Okay, cool. So that's all tokenizer. So the tokenizer... Oh, that makes sense. The tokenizer does a lot of stuff. So the tokenizer puts it into the shape that it needs to be. So if you have orange, so you have a model. This is your model, and your model is the thing that is the dog detector, and it tells you if a picture is of a dog. That's a dog versus not a dog. So that model is going to have a certain like desired input shape. It's like, oh, things have to come in that are shaped like this. Actually, that's a bad analogy. It's going to say, oh, they have to come in as rectangles that have the same number of rows as you have pictures or whatever. Like each picture has to be converted into a 10 by 1 string of numbers. So he's saying right now that the tokenizer does that. It brings in pictures and it spits out stuff that is like shaped appropriately. Yeah, because you can't. The idea is that you can't just take the picture and put it straight into the model. That doesn't work. You have to. I'm getting fast at this. Nice. You have to tokenize it so it will be in the right shape for the model to accept it. I realize I should be careful with the mic because I'm probably talking away from it. I don't know, who gives a shit. I don't know. It's like you get better over time, and it's just like increase n. How do you get good at something? That's how you get good at something. How do you draw a perfect circle? It's in there somewhere. Oh, dearie me. Blah 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 blah. Yep. As a tokenizer, there's also an auto model PT value from a pre-trained model there.
Hello? Where's the little API?
Yeah, see? That's the rectangle. It's a cube, actually. It's 2 by 16 by 768. So each sentence has to be put into a 16 by 768. Wait, no. Checkpoint. Start from the top. Haha, auto model. Checkpoint is this. So the checkpoint is like it was training in it. It's like quick save. Like as we're training this thing, we're going to pull quick saves out of it. Model equals auto model from pre-trained. Okay, so we take the checkpoint and we put it in there. I would love to just see what the fuck this is. This is probably a tensor, which is just going to be some big ass freaking number. Oh my god, this is hideous. Do you really do it like this in there? Is this why they do it in Deep Lab Cut like that? Dot capital S size? Well, I guess, what language is this based off? It's not Python. It's not Pep 8. What are you doing in there? PyTorch? Is that C? I don't know. I see, because I saw this in Deep Lab Cut of this. I mean, I guess in Qt we do camel case, which is not right, but that's C. Who does this? What language would do that? This rabbit hole I will go down. And this is for sure. I'll do it in Deep Lab Cut channel. This is Deep Lab Cutty, I think. Because I did see that happening in Deep Lab Cut. They use TensorFlow, and this is PyTorch, but those are two packages to do the same thing. It's like Python-based machine learning. Okay, so now I pull up my phone, and okay, so I'm going to record an audio message real quick and send it to the machine. So I keep seeing this thing in their code, the Deep Lab Cut code, where like they don't appear to be using Pep 8 guidelines, which is fine. That's what it's fine. But I saw something which I had assumed was just kind of like, for lack of a better term, sloppiness, where they were using in TensorFlow or something where like it was in like dot, and then the next thing was a capitalized letter, which is not standard Pep 8 capitalization. But then I was just watching a Hugging Face tutorial, and they did the same thing for PyTorch. So like using PyTorch as torch dot capital S size, and then something like that. So I'm curious what that capitalization schema might come from. Like, is there anything kind of in like the history of the languages that TensorFlow and PyTorch might be based off of that uses that? Because I'm thinking like I do, like when I write like Python PyQt code, I regularly use like camel case, which is like a C-based thing, even though it's not appropriate, and that's not Pep 8 for Python. You use it because the underlying package was written in C. So I'm wondering if there's something like that going on for TensorFlow and PyTorch that would explain like why I'm seeing like lowercase torch dot capital S size as the capitalization schema in PyTorch. Do you have any insight in that? Of course I do. This one might actually be hard for it. Huh? Oh, it's a class. Oh, it's because they're using. Oh, it's because it's what? Pep 8 recommends lowercase for function and provides the capital. TensorFlow, PyTorch follow this convention where classes like tf.tensor and tf.torch.size have capital first letters. Okay, so it's because. Okay, so I guess I was confused. So I guess like tf.tensor and torch.size are classes that are in the init file of the TensorFlow and PyTorch packages. So I'm confused by that, because I guess that's a fine stylistic choice, but I'm used to like importing classes rather than having to be like dot accessed from the main package. Um, so it's a class. I think that's right. I'm confused, but say more. I'm not going to listen. Are both made available? Yeah. Yeah. That's so it's I consider that to be older school because Endurance told me to do different. So it's like everything being exposed in the top level, I think, versus just like importing classes from where they are. Stylistic choices, I suppose. This is an opinionated review.
For between data, we got good cache configuration of the model, as well as the between weights. However, the automated API will only instantiate super data. That is, the part of the model that is left once proven.
You haven't talked about the head yet, dude. You gotta tell me what the head is. I hope you are you gonna do it now? You got 2 minutes.
In head, we belong to the high-dimensional tensor that is representation of the sentences class, but which is not directly used for word classification problem. Here, the tensor has two sentences, each of 60%.
The hidden size of our model. Hidden size. What's hidden size?
And as I mentioned,
Hour in, I'm tired.
768. Given that we think for classification problem, we need to use the automodel for sequence classification class. It works exactly as the automodel class, except that it will belong to the model to the classification head. There is one auto class for each element entity class in the transformer cycle. Here, after using our model to two sentences, we get
Okay. Thanks, buddy. I don't care. Give me the thing. Text classification. Punch it. Text. That's fine, actually. Okay, yeah, sure. Okay, so text wrapper, wrapper, text wrapper, print out printy text. Is that necessary? Yeah, sure, whatever. Now we suppose we like to predict the sentiment of this. Blah, blah, blah. Give me the pictures. Give me the pictures. I want the pictures. There we go. Meh, wah. Da 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 da. Da 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 da. And get clone. Give it to me. I wanna eat it. Fuck these sentences. Boring. One-dimensional schlock. This motherfucker showed me an Amazon review and wanted me to care about it. Get out of here. Alright. Da-da-da. Da-da-da. Plus, I don't need to do that shit. I'm good at this. Famous last words. How are we doing this? Good luck, my son. I wish you nothing but success. Okay, where are you going to get me to? Yeah. Are you where does this link to? Give me your cat. This is stupid, but I'm going to do it. And I'm going to love it. Yeah, let's do that. And where's the thing? Come on, what's going on? There we go. Do 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 do. Come on, come on. This is I'm doing this in the stupidest way to make a point. Okay, is that gonna work? It's just information. Information transferred by way of light. Okay. Alrighty. And where do I put it? Oh, fuck it. I see something up. Let's check this out. Just chew on that one for a bit. Okay. Everything after the question mark is not needed. No, it is. I'm wrong. I was wrong. Oh, because they started putting the authentication in the query has authentication information in it. Like these tokens. Okay. But you can probably do this. So, okay, so you want me to quick tour, install. Do I have it? You want me to run this from a console, which I'm down. I'm starting to see where a lot of deep LabCut style comes from, because this is very, like this is very from trans. Yeah, we got it. Cool. Import pipeline. So that thing. Do you not have a? Is there no installation? How to install it? You jerks. What the shit is this? Pi project in here? How did you install it? What did you, okay, so pip install -e dot bum ba-dum ba-dum bum. Wait, what was it? Give me your cat. I will show you this cat, and you will tell me that it is a cat, and that is how we shall know that we can communicate with each other. Skellybot already knows. Oh, how do I install that? God damn it. You're not going to tell me, though, huh? Great. Let's put the installation below the demos. That's a great idea. That's exactly where people are going to look for it. They're gonna get to the top. They're going to be like, blah. It's actually true though. Like, I want the demos first, but when I'm using it, I want the installation first. It's fine. I wasn't using that one. Speaking of transfer learning. I was using the, oh wait, no. Exit. I'm going to gunk up my DLC environment with this, but that's fine. Pip install transformers, but it's already in there. Nope, it's not. There you go. There you go. There you go. BlenderBot. Oh, no, different Blender. Bring me your cat. Give it to me. I'm not going to need import requests. Wait, I don't need that one. From PIL import image. Seriously? Pillow. Boop, 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 boop. Is there like a scripts, benchmarks, examples? Cat? Where? From pill import image. Great. From transformers import pipeline. I know that. Wait, I know this one from Aaron's thing. Because he gave me the gift of a command that will, wait, how do I not have TensorFlow in that DLC thing? Shit, but it wasn't seeing Conda, was it? I could probably handle this one without a GPU. It's just going to be a single image, so it'll be fine. Okay, image data. Bum bum ba 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 dum. Image equals image dot open. Wait, what the fuck is even? What do you want it to be there? I guess I can use your stupid request things, but you're gonna be like, I've never heard of requests before. It's fine. Oh, import request is a built-in. Yeah, fine. I'll use your dumb picture of your dumb cat, and then I'm gonna just because I want to see what your like. What do you call data and what do you call image? I guess data is probably gonna be like the numbers, like the unsigned integers and all that. Image data, and then image is probably going to be a PIL class. This really just calls it open though. Whatever. Should be create requests dot get URL stream equals true, which I think is just a speed thing. Dot raw. Great. Who are you? Oh. It's raw. Okay, so there's just some kind of anyways, image equals image dot open image data, and you're gonna be yeah. I can't display it though, can I? 640 by 480. It'll be this picture of a cat. Object detector equals pipeline string. Okay. Yeah, I'm gonna do this in a better way. Where are you gonna be? Let's be in. Oh, this is y'all's. This is y'all's. So new. It's fucking whatever. Cat detect. I don't plan on doing any work in here. I need a playground folder on this computer. I haven't made one of those in a while. Just kind of like for all my. Copy to clipboard. You gave me all the stupid. Yeah, you are. Okay, and I hit Alt J. Bye. And I say, get all this shit out of here. Thank you very much. Bye. I'm gonna say grab it. Oh wait, no, hit that. Now I'm gonna do F11. Control C. Got that. Go over here. I'll say. Oh, I'll do this in the right place. Python /chat. Give me this, but for load the file from disk. Straight shot, it'll do that. I am confident that it will one shot that. Doink. WebP. I don't know what that's all about. I don't know if it'll like the WebP. If it doesn't, I'll just ask the bot. Dearie me. All right. Oh, I forgot to put the breakpoint in. What did it want? It went Tim. Pip install Tim. But I was on Deep LabCut when I did that. Was I? I can't remember. Cat. Hit. It's a hit. It's a hit. Stip. You're gonna yell at me, huh? It's fine. We'll do it later. Okay. All right. You gonna yell at me? Pip install Tim, but was not found in your environment. And this again is a thing that I saw on Deep Lab Cut, where like importing it is slow, which is like it's a choice. Yeah, so here's the image. It's a WebP image. The size is a weird one because it was just like a random manual crop. Here's the memory address, which is cool. And then we're going to try to get this guy here. He might yell at us. Yeah, import error. Okay. Why don't I have Conda on this computer? Oh, it's on this terminal. Okay. I don't like Anaconda, but it is by far, as far as I can tell, the easiest way to wrangle like Conda shit or CUDA shit. But I don't like it because it's like, why you follow me around? Like, get out of here. Like, I shouldn't be. You shouldn't be offering me up these other environments in this different project. That's just gonna lead to the thing that just happened. I was like, oh, let me just like slap it in Deep Lab Cut. Interpreter. Conda connect now. Create a new environment for that. 3.8. Are we on 3.8? For real? No, he said 3.11. Oh. It wants to say 3.8. Where are you getting 3.8 from? A lot of these things are pretty behind the curve. I want to be done. Python in general feels, it's just like, keep up. I agree with Endurance on this one. Like, I mean, I agree with him on everything. If it's about like, yeah, 3.8. I implicitly agree with him on anything related to code, but he said Python needs to fucking step their shit up and like keep up with the modern languages, and I agree, man. It's like I'm ready to walk away from it because it's just like, we like it sloppy. It's like, I guess. Okay. So I still don't know where it got 3.8 from, but it makes sense that it would think it wants 3.8. Because it says that, like, I don't know. It says 3.8 plus. Oh, okay, here we go. Oh my god. I mean, yeah, also give that to Deep Lab Cut. They tried. I mean, they did a lot to make it like as simple an install as possible, and like they do, like putting out all the CUDA shit, and that's all in one little YAML. Like that's, I appreciate the shit out of that. You gonna pop up now? Nope. I mean, I could just use this here because you have TensorFlow in here and CUDA stuff set up somehow. Maybe not though. Maybe I didn't do it on this one. I don't want to fuck up the Super Animals one because that was the one I was using. Make a new one. I'm gonna tell it to. I'm just gonna let it do its defaults, because I don't plan on using this one anyway. But it's like when it's that far out of date, because we're on like 3.12 and like moving on to 3.13, and like you're still recommending 3.8. It's like now when I hit a problem, it's like, wait, is it because like are you out of date with somebody? While I am here. Okay, so we got this one. Get started with. Fuck off. Okay, so now can I do with the cat? You still gonna say I don't got Tim? Wait, so I did that. I did that. I did. Wait, no, because I had this thing from an Aaron where he did show how to. Like that's yeah, because he has this command on how to install this stuff. CUDA. Oh, but that's CUDA. That's not PyTorch. Fuck me. Oh, this is TensorFlow. Great. Windows native. Oh, you're saying this is TensorFlow. Okay. Sure, let's give it a shot. We'll do it one at a time. What did I just do? Oh, it's the TensorFlow one. Don't mind me. Yeah. Okay, buddy, we got this. We gotta do this part. Pip install. I'm just gonna say install everything that you said I should install. I better include pill and Tim. I'm judging you. I'm judging you. I shouldn't be, because really it's like glass houses and shit, but here we are. It's called Pillow. Also judging you for that. Python image library, I guess is what it's called, but like I don't like it when the import is different from the pip install. And you want to say pip install Tim? You told me to do that, but I feel like I already did it. Well, now we're doing PyTorch? Don't give me any shit where it's like, oh, you got PyTorch and TensorFlow in the same place, because you told me. Be done. I want to see a box around this cat. Then we'll be good. Okay? Is that too much to ask? Rectangle? You know what you're going to say? Like, why don't you just follow the instructions? It's like, I don't want to. I'm special. Didn't you know? RTFM is for the other guy. Good. Thank you. What's going on? Where are we at? Do we... Okay. Once again, we're in the space of the import. Takes a long-ass time. It's fine. It's Python. It's slopfest anyway. Give me this picture of my cat. Good job. Spectacular. Okay. Don't fuck this up. It's okay. We're not in production. It's a demo. Are we still thinking, though? Are we still thinking? You thinking about something? Some weights on the checkpoint are not used. This is expected if you're initializing. This is not expected. The max size is deprecated. That's the thing I was hating on from DLC. Will be removed. Please specify in longest edge instead. Are my complaints about the software world, does it go all the way? Is it all? It's like, have my standards become fish? Am I fish? And I'm like, no one. No one is good enough. How do we find a way to say that nothing you've ever done, ever could do, or ever could possibly do is good enough? How do we say that in like a supportive way? like, no, like of course it isn't. Like, are you kidding? Like, rule number one, man, science is impossible. Like, you know, like achieving satisfactory performance is a failure of perception. Like, the second you see that it is possible, I am sorry to say, is the moment you realize it could be done better. And I think the trick is just like learning how to be okay with that, like understanding that like that's not a dig, that's just the situation. Like this is beyond any of us. Like, did you think that you were able to like? Did you think you get to know things? Did you think that knowledge was possible or even philosophically feasible? No, my dude, no. What did it? What did it do? What happened? Did I get it? Is it a cat? Please inform me of whether or not this is a cat. Did I do the thing? Did I do the thing? Give me it. Give it to me. Show it to me, the image you see. I must see this image of this cat. This, you, Show it to me. Where is this cat that you promised me? These fuckers love IPython. What's the output, man? What's the output? Print. That's not what happened on mine. Here we get a list of object detector. How do we get that out of there? Device, model, task, framework, model card. Okay. Oh. What's in the call function, I guess. All right, well, give me your dumb cat. Because I don't know if you like this WebP thing, and I don't want to convert it into something. And to be fair, that is a really shitty picture of a cat. And it also, it specifically said, like, you're not tuned for this. It's like, okay. 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 Okay, 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 okay. Bonk, bonk. But you better give me... Oh, I think I need to just capture the output, as they say. Result. Print F result. Thank you. Oh, because it's just regular ass object detector. Okay. Okay. Cool. So we did get that to work theoretically, not in a very satisfying way, but like it came back with 4 numbers, and they're the ones we would expect. I'm gonna give it one last good shot of a better picture because I got better pictures. You know I do. Give me the cat and show me the cat. Where it is at? Who was like, what? Where is it? Control Shift or Windows Shift S. On Mac, it's like Command Shift. Five? Where did it go? Where did I save that just now? Pick, 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 pick. Okay, thank you, thank you. Bam, 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 bam. See, this is how you write. This is how you write. This is how you write grad student code. You're just like, fuck it. I'm just gonna do this. I don't care. I just want it to work. What's the word? Non-pejoratively. Because when you're new at something, it's just like, you can't even imagine that it ever could. Like, the idea of something working is such a foreign concept that if it ever does work, it's like, holy shit, I'm done. And eventually you're kind of like, no, actually things sometimes do work. And the thing that's hard is like using them again for a different purpose. Transfer learning, you see. It's not the same thing. Spaces in the file name. Never a good idea. Give it to me. Nice. All right. So we got a cat. We got 2 cats. Oh, man. Okay. Did I turn that guy's thing off? The image viewer. I want to be done. Background image plus OpenCV viewer. Well, why not? Is it only OpenCV? Oh, it's only. God damn it. Oh wait. Premium. You fucking piece of shit. Son of a bitch. Fucking cunt. You motherfucker. I will find you and I will fucking end your life. Ugh. Fuck your freemium. Oof. I fucking hate you, you piece of shit. Hiding fucking pill behind a fucking paywall. You fuck. You fucking asshole. Who the fuck are you so I can know you that I hate you? Pseudo? Oh, I fucking hate you, you piece of shit. Ugh. I get it. But go fuck yourself with a monthly subscription to see fucking Pillow. Oh my god, I'll fucking I will fucking smother you with a pillow, you piece of shit. Are you a company or a person? You're a person. I get it. I get it. I understand, but I fucking hate you. Fuck you. Fuck your freemium model, you piece of shit. Sorry. I understand. You're just trying to make a living. I understand. But it's like, I also understand how fucking easy it is to convert a NumPy array to a fucking pillow image. And so now your ass is trying to use your fucking ability to understand how to do a simple fucking line call to make me give you a monthly fucking subscription. Has it... Did a kid do that? Is there like who's paying you? Who is paying you? Who are you taking that money from? Andre, or what the fuck your name was? Who is paying you a monthly subscription so that you can convert a NumPy array to pillow image? No, I'm not gonna do it. Just like, ask yourself, because right now you are trying to make money off of me because of your knowledge of how to run how to view a fucking image, and I know how fucking easy that is. See, what you do is you ask the machine. How to convert a pill to a NumPy image. It's probably some fucking call, like to NumPy or some shit. Oh, you just call it as a NumPy array. Oh my god, that was some good... I felt nice and righteous in that moment. That was some good righteous anger. And it's like, I always try to like remember the human, but this is a case where it's like, oh, actually, I can very easily imagine myself. No, I can't actually, because you live in Poland. Like, who knows what you need the money for? Like, maybe this is enough. I don't know what the fuck's like in Poland. I don't know like how many, but it's just like it's just the thing. It's like it's a moral stand that you should not put simple knowledge behind a fucking paywall. And it's a SaaS. Actually, you know what? I'm okay with this. Fuck you as a human, your fucking SaaS model. Your fucking freemium SaaS model bullshit for a single fucking call. I feel great, actually. I needed that. Here at FreeMoCap, we are aggressively open source. Langchain was like, we're proudly open source. Fuck you. Fuck your pride. I don't have pride about open source. It's the only fucking option that is morally defensible. And I am here to crush your fucking business model if you believe anything else. I don't agree. There is no room for discussion. We will not agree to disagree. You're wrong, and I hate you for it. How to survive in 2024. Some people are fucking wrong. Oh, we get a alpha mask out of that. And so now this, I can view. Oh, did I delete it out of anger? I might have. I'll still use your shit. I just hate you the whole time, and I'll say that I hate you every time. No, it's there. Cat. You see? I'm sorry, sweetie. No, you're good. You're good. Alrighty. Punching on through. Where are we at? Okay. Detect cat. Speaking of some bullshit, what the fuck are you talking about? You can't. Oh, I don't know what that is. It's the fucking raw data of an image, you piece of shit. Why are you telling me you can't take that, you fucking coward? I'm salty now. Oh, because we're at 2 hours. The saltiness increases stepwise. These are the things that we learn about ourselves. I know. I have decided, by the way, that I am just gonna be angry about. I'm open source zealot. FOSS, free open source zealot, is is the new vibe. We have to harness our anger and point it at something. And I've decided to point it at everything. Did I do that wrong? I know. I moved you. Now I'm. Okay, F8, F8. Yep, you just yell at me because I don't have the thing. It's fine. That should work though, right? Yeah. Okay. So bounding box, X max, X min, Y max, Y min. Because we want to verify. Okay, so X max. Can I draw on you? Is that the thing you let me do? Okay. So there's a 99% chance of a cat being in this first box. What's this second box? Oh, the box. It's just the box. Label, cat. Score, very high. Sweetie, did you know that? Did you know that you have a very high probability of being a cat? Never 100. Never 100, but pretty high. I know. It's a hard life. Okay, so 436 to 17. Where'd it go? Oh wait. Doink. Oh, don't delete that. Okay, 436 to 17. So 17. You can't see that for shit, but it says on the bottom 17. And this is going to be 436-ish by around here. 436 is here. And Y, 49. Wait, yeah, Y counts down. 49 is here. And then down to 265, which is going to be here. Yep. Nailed it. Cat detector. Boom. And it was kind of fast. Okay, so I got to go now and do some nice fun Sunday things. And, Jesus Christ in space. But we've got Transformers on our side now. So we're going to go through and we're probably going to, well, we can crop some stuff. We got to build ourselves a cat model. So we're going to crop out a bunch of pictures of you, and then we're going to label all those, and then we're going to feed them into the machine, We're going to train up a model to detect you. And then basically once you have something out, like we could start on the other part anytime. It's just not as much fun until the data's good. But once we have something that's spitting out data in roughly the right shape, we can start doing the reconstruction and the Blender pipeline stuff. Just on the assumption that like as the data gets better, the results will look better. I might also just take that opportunity to work on Steen's data and work on like the OpenPose to Blender pipeline, because that should be much easier, much more straightforward. Actually, I should do that first, because it's like, well, it's just one additional unknown. Instead of MediaPipe, it'll be OpenPose, but it'll still be a human. And then once I start getting the kitty ready, if I've already gotten, then it'll just be like, oh, now it's the fact that it's not MediaPipe is no longer weird. The weird part is that it's not a human. So always better to solve one unknown at a time. Okay. Goodbye. It's been fun. Hope you're having a good day. I'm sorry, Sergey, or whoever your name was, Mr. Poland. I'm sure you, Adrian. You have a job. Go fuck yourself. You're Lena. Don't use Lena. Use Hedy Lamar. Okay, bye.